Hey everyone, welcome to the the first afternoon session on seafloor sand and sediment management. I'm Ursula Housen. I work for the Renewable Energy Office at BOEM, but we're not here to talk about offshore wind or anything like that. We are here to talk about the work that my colleagues are doing. And so these folks, two of them at least, are from BOEM, from the Marine Minerals Program. We have Jeff Waltner, who is a physical oceanographer. We have Victoria Brady, who is a biologist. And then Daniel Warner, down at the end, is working with both of them using some BOEM funding to examine 100-year projections of, I think it's sand use. So he'll talk about that in more detail later. And then hopefully we'll have some time at the end to field questions and to discuss. So please, again, just hold your questions until the end. And I think, Jeff, are you ready to go? You first? Okay, take it away.
Hi, everybody. Thank you. My talk for today is BOEM's Holistic Systems Approach to Sand Resources and Ecosystem Balance. So what does holistic systems approach mean? So for everybody, it's a little bit different. So what I ask you to do is picture yourself on the beach looking out at the ocean and looking at all the resources that are available, and think of sand, sediment, the landforms, the geology that represents. Then look at the beach, look at the dune, then look, one way down beach, and then look the other way down the beach and realize that things are changing constantly. Then we turn around, put our back to the ocean, and we look at all the ecosystems that follow successively and understand that those landforms are controlled by the sediment, the sand, the geology of those ecosystems that follow. Holistically, everyone has a different picture of what that means, what the health of the ocean means, what the health of those landforms mean, whether we live, whether we work, play, study those areas. So BOEM has to acknowledge that and respect those opinions. So, and that's the approach that the Marine Minerals program takes. So, government agency, I have to show you my authority slide, but basically, well, we look at it as our stewardship responsibility slide, okay? And some of us call ourselves, maybe we could call ourselves the stewards of the sand, just as a monkey here, okay? So basically, for people that don't know, federal jurisdiction begins 3 nautical miles out. Land, submerged land, in-state is in-state waters. Do we care about how states manage their sediment materials in-state? Yes, because we know that when those resources run out, they'll come knocking on the federal door. And we want to be ready and coordinated for that. And in some areas, that's all too soon. So they're basically, if you look at the organizational chart of BOEM, there are a lot of different boxes and things. But basically, there are 4 basic programs for BOEM within the Department of Interior. One is the Office of Environmental Programs. The next is oil and gas. There's a renewable energy program. And then there's this small little marine minerals program. But we like to think that we're small, it means agile, and we can address people's concerns. So give you a little bit idea of the marine mineral program. And as I said, we consider ourselves a stewardship responsibility. So that's what we have in our mission statement, and that we perform prudent exploration and leasing activities, coordinate with our government partners, stakeholder engagement, and mission-focused research to improve decision-making and risk management. So we promote that through coastal resilience, through infrastructure protection, ecosystem restoration, and resource sustainability. And the Marine Minerals Program does not do projects. We coordinate with states, different agencies. For instance, NASA at Wallops Island has multi-million-dollar infrastructure. That would be very costly if it were not protected. And so we provide sediment resources to NASA for that. So some facts about sediment and sand offshore. The demand for sand is increasing, and we'll hear later, Dan's going to talk about that. Sand is a finite resource, and federal agencies, states, and municipalities request OCS sand for coastal restoration projects, and they do that with no cost. We don't charge for sand. So sometimes we have the hard task of being the free sand program, and that sometimes doesn't help us. But it basically, particularly after storms, you're not going to ask a state that's really having a hard time to say, we need funding. That doesn't make sense. So understanding the impacts from dredging is also critical to foster ecosystem balance. And a lot of that environmental task, Victoria is going to go into further. And this is a project that we can work with Maryland and the Baltimore District Army Corps of Engineers in 2020. And that will be, that's scheduled, next renourishment is scheduled for 2025. So traditional sand management, and this is years ago, probably pre-Sandy, I guess we could call it. I'd like to think of it as in taking instructions from the back of a shampoo bottle. They're all the same. It's shampoo, rinse, repeat. And the instructions then in sand management was storm, replenish, repeat. So it's easy with shampoo. When the bottle is empty, you just go to the store and buy more, right? But sand is finite. That store will be exhausted at some point. So what do? So as you can see, there's a very closed cell project to project tasks, and everything is we're not doing we don't know enough. We need more data. Our ecosystem balance in our judgments, our best guesses, trying to do the right thing, and sometimes planning happens over in the lower right as our project is great, but we don't realize that there's a wave behind us. So ideal sediment management is when we use all our resources wisely and in a scientific way, using a lot of data. We know where our turtles are. We know where our fish is. Like yesterday I was thinking, oh, this is like ways for whales when we were tracking real-time whales, right? If we know where they are, maybe we can avoid them, real time. This would be, so if we do, sediment bypassing, better knowledge of those things, sand is going to move. It doesn't have, unlike people would like to think, they don't, when they put it on the beach, those that do, it doesn't have a property sticker. It goes somewhere else. And oftentimes, it ends up as habitat somewhere else. And that's not necessarily a bad thing, particularly when we've stressed out our coastline so much. So if we do things in a wise, coordinated fashion and supplied by many different data sources, we can make better decisions. And that's part of the stewardship responsibility that we have. So talking about the physical, before we get into the environmental, we look at things that, one statement is, coastal resilience capacity is going to depend upon how much sand and sediment we have in the system, or bring into the system in the case of the OCS. Okay, and that's going to be supply and demand, resource evaluation, risk mitigation, and borrow area optimization. So this is a teaser for Dan's talk, but a couple of years ago, I was talking to the folks in Belgium, and Annelies de Backer said, I asked her, I said, how far in advance do you look at your coastline? And a lot of their jobs are aggregate for construction, a lot of dredging, and the rest is some coastline restoration. So they have dual purpose. We don't have that yet. And she said, it's interesting. We look 20 or 30 years in advance for coastal restoration. But aggregate companies, those same people that dredge for coastal restoration, they look at a 100-year timeline, because if they can't see 100 years, they have to transition their business to something else. And we're in the business longer than 100 years, aren't we? If we're interested in being stewards of our coastlines. So we have to think a little bit different. So part of that is a New Jersey cooperative agreement we have with the New Jersey DEP Geological Survey, is to look and plan where our resources are for the future. And the changing environment is, we've all realized and recognized, is wind energy. And it would be easier if all of that was segregated. And to a certain extent, wind energy is 8 miles off the coast, 26 miles of coast, where it's very expensive for that sand to be delivered to the coastline. However, for us, transmission export cables can cross sand resources. And the actual cost is not the sand resource that is actually displaced, but it's where that cost is actually where we have to go to find more. And it's farther out. So instead of finding a resource that's 3 miles out, because of that crossing, we have to go 5, 8, 12 miles. And that's a transit cost that just gets much more expensive. So we decided that we had to find out where these resources are. We have all these resources. They're on the derivative maps or on the ocean portal. Find out which ones are the ace of spades or the two of hearts, and which cards to play. And I would mention with that is we found in talking to the folks in Europe that where there is one cable, 5, 10 years later, there's going to be 5. There's going to be 8. And it's like your kitchen. Rewiring your kitchen, and you go to the electrical contractor and he goes, that dishwasher, that needs a home run. That refrigerator, that needs a home run. The microwave, now code says that needs a home run. So you have all these wires running to your circuit box, and he's, upgrade to the next wiring. Next one is, we realize that it's cost sustainable. Is cost sustainable for beach nourishment projects? So one of the things that we know of from South Jersey down to Florida, and years ago, we used to extract heavy minerals from sand. And can this be done, and is there an economic advantage? And in the case of Virginia Beach, the project that was completed recently, it was 1.84 million cubic yards, and taking the samples from that beach, we realized it was 19.91 million in estimated value in critical minerals. Critical minerals are important. They're in our phones, they're in new electric cars, EVs, and a lot of them are artisanally mined. So ethically, should we be extracting these minerals? So finally, I'd like to leave you with Coastal resilience and capacity and ecosystem balance is driven by a sand inventory. And advanced planning and research is critical to meet growing demand for coastal resilience projects. And it's important for us to optimize the national sand management strategies, proactive and adaptive to coastal community changing needs, and stewardship support of ecosystem balance through environmental research. All this is found on the MMIS, which is on Marine Minerals website at BOEM, and is also found, the derivative maps, the sand resources maps, are found on the ocean portals, both Northeast and Mid-Atlantic. And you can find both the resource evaluation and our environmental studies on our map. And as I said, it's important for us to leverage our investments and to listen to our stakeholders and to work cooperatively. These are some of the states that we've worked with, whether they be contractors, the Army Corps of Engineers, and our other brothers and sisters in federal government. So thank you very much.
Okay, thanks, Jeff. Okay, next up we have Victoria Brady talking about habitat.
Excellent. Thank you, Ursula. Good afternoon, everybody. My name is Victoria Brady, and I am with the Marine Minerals Program. You just heard from Jeff talking about kind of the geological side of our projects. I'm going to be focusing a little bit more on the environmental and biology side, which is a bit of a sneak peek for the next session. And Dina Hansen is my co-author on this. She's not able to be here, unfortunately, but I will have her contact information. She is the lead on a lot of the projects that I'm going to present, so she's a great resource. I know Jeff did show this slide. I just wanted to make the connection. We're in the Marine Minerals Program, and we work very closely with the Office of Environmental Programs. And so I just wanted to make that link here. A lot of the studies that I will mention are done kind of in coordination with them. All right, and again, I'm just going to briefly go through these because I know that Jeff talked about them a bit. But I just wanted to reiterate that our program is responsible for facilitating access to these resources. So in order to do that, we have to know where the resources are and what the environment is in those areas. That way we can properly evaluate the environmental concerns. And BOEM is almost always a partner on these projects, so we really rely on stakeholder engagements. All right, so we know that demand for sand is increasing, and sand is a finite resource. So we need to make responsible decisions when we're leasing these areas for dredge projects. And part of that includes understanding what the impacts are from dredging. And so a lot of our studies relate to these impacts, so I just wanted to briefly go over them to give you just a little bit of a background. And so dredging can result in a change in the seafloor shape, benthic disturbance and removal, direct entrainment of animals, noise from the vessels and the machinery operating, vessel strike, turbidity, sedimentation, and emissions. So the pictures that you see are two different types of dredges. On the left, we have a hopper dredge, which is the most common for our projects on the outer continental shelf. And the small arms you can see they kind of serve as vacuums. So the dredge is moving along and those vacuums are sucking up the sand on the bottom. On the right, we actually have a cutter head dredge, which is less common, but I did share this picture because it shows some of the impacts here. You can see some of those turbidity impacts. I'll also note this likely wouldn't be a BOEM project because, like Jeff said, our projects are 3 nautical miles and further offshore, but it was a convincing photo, so I thought I would add it. All right, so as I mentioned, we assess the impacts through our marine minerals and environmental studies programs, and the research helps with our compliance with laws like the National Environmental Policy Act, or NEPA, Endangered Species Act, just to name a few. And our ultimate goal is to identify mitigation measures that we can apply to projects to minimize impacts accordingly. And just some common research areas that we focus on: habitat and ecology, protected species, and fates of effects of activities like dredging. And then all of our final reports from these studies are publicly accessible on this website in the bottom right. Okay. And so we identify studies that are needed through various channels, through internal, external assessments of activities, also stakeholder and partner engagement. Those are, as we've heard many times, very important. And then sometimes other studies help us identify data gaps that might require further investigation. Okay, so now I'd like to share a few examples of these studies that have been completed or are ongoing in the Mid-Atlantic. The first study I want to mention is called Shoalmate, and the goal of this study was one, to build a GIS tool to support essential fish habitat consultations, which are required under the Magnuson-Stevens Fishery Conservation and Management Act. Two, to incorporate dredge impacts more accurately into these assessments. And three, improve mitigation for our projects with this tool. So this was a great study because it was able to produce an actual tool that we are able to use in consultations. And this is also an example of how we can take our geological data and incorporate it into our environmental studies. And the data that were produced from this study can be requested by the public, and some are actually available on public databases. For example, there is a shoal feature that is hosted on the Marco portal, and this can help the public and BOEM with planning. And that's just a shoal feature, so it shows areas that the model predicted to be shoals. And so how does Shoalmate work? It incorporates several data layers, as you see here. It incorporates physical characteristics of sand shoals. That was that layer I was talking about that's on the Marco portal. It also incorporates distribution of fish species based on species habitat relationships. It includes the boundaries of essential fish habitat, which, if any of you have ever done essential fish habitat consultations, those boundaries can be very broad. And past dredging activities. So with those broad boundaries, this tool is supposed to help kind of fine-tune these assessments. And so all of these layers go into the tool, and it creates an assessment report that can then be used directly in these consultations. And this was quite a large undertaking, as you can imagine. A few of our partners were Quantum Spatial and then NOAA Fisheries for a lot of the, especially for a lot of the fisheries data. Okay, the next study I want to briefly mention is the New York Bight Fish Study, which is a cooperative agreement with Rutgers University. And Dr. Thomas Grotus will be presenting in the next habitat session, so this is just a teaser. But the objective of this study is to characterize and quantify fish association with New York Bight habitat features. And this is important because this is an area that may be dredged in the future. So I know there was topics or discussion earlier of pre-activity data. So this would be a pre-dredge data set. And this study does have two phases. So phase one was an analysis of fish distribution using existing data relative to known shoal features. And now they're in phase two, which is the field effort for fine scale and regional tracking of fish to see how they're utilizing the habitat. And so there's various methods that Dr. Grotus will go into more details on, but what you're seeing on the screen is the AUV used for the study, and then we have side scan sonar in the middle showing a school of fish with the shadow, so they tell me. I think he may be able to explain that a bit more. and then a sample from the trawling survey to help identify fish species composition. And I'm not going to go into too much detail here, but a few initial findings. In some cases, pelagic fish habitat is structured by bottom features. Results of the bathymetry surveys correspond with the benthic species richness and abundance from the trawl component of the survey. And then acoustic telemetry will validate these findings. And this, again, is important because if dredging does occur in this area, we have a great research already done that can then continue. Make sure to stick around for his talk in the next session. And let's see. Another study we have is the Sandbridge Shark Study, which is a cooperative agreement with the University of Delaware. And the objective here is studying 6 highly migratory species with essential fish habitat in Sandbridge Shoal off of Virginia. And this was actually identified as a data gap during consultation with NOAA Fisheries. They mentioned that there was very little known about highly migratory species on this particular shoal. And so we were able to propose a study to try to fill that data gap. And this includes longlining to tag and track using fine and regional scales. And the study's in its 3rd year. And Benjamin from the University of Delaware will be presenting in the next session. So just another sneak peek for you. Okay, and then the last study I wanted to mention for the Atlantic region is another Sandbridge study, but this one is a partnership with the U.S. Geological Survey, and it focuses on Atlantic sturgeon. And so there's 3 objectives. One is to characterize sturgeon occurrence near sand resources. The second is to monitor sturgeon distribution before, during, and after dredging. And then the third is to document behavior after relocation trawling, which is a current mitigation measure that's in place from NOAA. And so sturgeon are protected under the Endangered Species Act, so this is particularly important for us to understand so that we can make sure we are applying appropriate mitigation measures to protect the species. I also wanted to just identify that we have other regional and national studies. These are a few related to protected species. We have studies on sturgeon, manta rays, and sea turtles. We also have several ecology studies on specific shoals, including frying pan shoals in North Carolina, Ship Shoal off Louisiana, and then Canaveral off of Florida. And lastly, we have some operational studies on dredge operations, sediment infilling, and acoustic profiles of dredging. So I just wanted to show that our research extends beyond this area, and it can be quite diverse. All right, so some key takeaways. In the Marine Minerals program at BOEM, we really value our ability to propose science projects to support our outer continental shelf mineral management. And sand features and the surrounding environment are coupled, and understanding that is critical to our management decisions and being responsible stewards, as Jeff mentioned earlier. We work with a lot of partners, and our work wouldn't be possible without those collaborative efforts. And then finally, being forward-thinking helps us make sure that we're making responsible and sustainable decisions as best we can. Oh, sorry, yeah, okay. I think I skipped ahead a slide. Okay, so here we are. So we're always thinking of new study ideas and areas where we can improve. And climate change is definitely an area where where we're focusing, and especially considering how this may impact ongoing research with changes like habitat shifts. I know that was mentioned earlier, but that can be very challenging, especially with species management. And then also with increasing demand for sand, it's important for us to prioritize studying areas that will likely be targeted for sand resources. And then again, our stakeholders, these are just some of the ones we frequently work with. In addition to all of the universities I mentioned today, we really appreciate our partners and couldn't do our work without them. And as promised, my contact information and Dina's contact information if you want to reach out to us directly. Thank you very much.
Okay, thanks, Victoria. Next up is Dan Warner with the Delaware Geological Survey.
All right. Hey, everybody. Can you hear me? We're good. All right. Yeah, I'm Dan Warner with the Delaware Geological Survey. Where Victoria and Jeff were talking very big picture. This is more of an example of what a more targeted study looks like with their kind of work. I think I have the fewest number of logos of any presentation here. So I'm going to talk about modeling and mapping 21st century beach sand supply and demand, focusing on Delaware and Maryland from a previous study, but we're actually expanding the study into the future. I'll go through this pretty quick. I bet everyone here knows about beach nourishment. It's been really popular in this region since the 80s and 90s, but does date back to like the 20s and 30s in some cases. Historically, it was more reactive. A beach would be eroded over many years, and then they'd say, oh, we need some sand. But more recently, in the past 30 years or so, beach nourishment has become more frequent and more regimented to try and be proactive for coastal stabilization. Within this time period, sand's primarily been mined from state-managed waters, but as Jeff said, that sand is beginning to become depleted, and we need to start looking further out to meet these sand demands. And small amounts of sand can come from ebb shoals and reused dredge materials, but generally, big beach nourishment projects require sand dredging from offshore shoals that aren't renewable on the timescales that we are thinking about. The pros: preserves the tourism economy, protects storm surges, maintains beach habitat, but obviously major ecological disturbances. It's very expensive, and it has to be repeated over time. So we enter this cooperative agreement with BOEM to think long-term about what's beach nourishment going to look like in 50 years, 100 years. We've been doing it for about 30 years. We've used tens of millions of cubic yards of sand just in Delaware and Maryland. Over the whole mid-Atlantic, we're probably 150 million cubic yards in the past 30 years. And when we start talking about this, you talk about volumes that are incomprehensible to the mind. And so I was looking for a visual aid, and I found this picture from an article. Everyone remembers the great cheese surplus of 2018. But Vox made this figure that's a 900,000 cubic yard wheel of cheese next to the Capitol building. So if you think of 1 million cubic yards of sand, imagine standing in front of the Capitol, but it's a sandcastle that's a 1-to-1 replica. All right. So for our previous study that we wrapped up last year, we focused just on the Delaware and Maryland Atlantic coast, primarily Ocean City, Fenwick Island, Bethany, South Bethany, and Rehoboth and Dewey Beach. It became very obvious that these 4 areas were by far the biggest consumers of sand. So we wanted to forecast how will sea level rise and climate change affect beach sand demand over the next century? How long can the current borrowers that we're using sustain that demand? And knowing that we'd probably need additional sand resources, develop a way to model potential sand resources, and so they may be used for planning with ecological conflicts or other offshore use cases. So this is a figure that Jeff had in his presentation pretty much. So the first step was to forecast sand demand. So we looked from 2021 to 2100 and used historical beach nourishment data to establish a baseline. And then we bootstrapped sand demand forecasts under different climate change scenarios, looking at the increase in potential major storm surges under different climate change, like RCP scenarios. We saw historically we've used about 33 million cubic yards in this region since 1991, just between these 4 municipalities. not municipalities, but beach units, let's call them. And we forecast that this area is going to need 50 to 150 million cubic yards of sand by 2100. So now think like you're standing in the National Mall in Washington, D.C., and a large chunk of downtown D.C. is just made of sand. That's how much we need. It's a lot. So then we wanted to look at the longevity of the current borrow areas that are being utilized. So this figure shows in blue, dark blue, our active borrow areas in this region. In red are inactive, which means either they've been exhausted or they were found to be critical habitat, so we can't use them, and rightly so. And then the light blue are areas that are proposed and have been identified for future projects, primarily serving Ocean City, those ones. And those 3 big shoals offshore are all in federal waters, so those are already BOEM-managed shoals that are being used. And we estimate that all these communities will probably need a new sand source at the 2050 to 2070 range. These numbers are obviously very useful for planning, but they're also based on a whole lot of assumptions like how good is the sand that's left in these borrow areas? We're not sure. How much will we be able to alleviate demand with reuse of dredged sediments or dredging the outlet shoals? And then like Caitlin kind of teed up this morning, this whole coastline had a ton of artillery units on it, and there's a lot of unexploded ordnance off the shore of Delaware and Maryland. And if we run into a bunch of those and that begins to become a problem, you might have to abandon a sand resource and look for something else. So the next thing was, we know we're going to need offshore sand resources beyond what we currently have. So how do we identify these? And this map is kind of a grainy downscaled map that some of my colleagues made in a previous cooperative agreement. It's actually a really beautiful big map that we have that you can download. It won an award. I was not involved in it. It's a traditional geologic map, so like each of these geologic units has paragraphs of information written about it. It's super detailed. And all the black dots are vibrocore samples that they used to make this map. So we're spoiled. We have a ton of data right off the coast of Delaware, but not very much elsewhere. So we need to look at a much bigger picture, and we were wondering how to do that. So my background, I'm not a marine scientist. Rodrigo, who presented yesterday, was my PhD advisor, and I did terrestrial carbon cycle modeling, and focusing on like digital soil mapping and using terrain analysis and things. So we were wondering, can we take ideas from that field and using bathymetry, can we model potential sand quality? So first we took all the core data we had available to us, and I reviewed I think 500 of these core logs, looking at each layer and taking a mix of qualitative and quantitative data and just breaking it down into this sort of unitless sand quality score. And then we use that to make high scores corresponding to areas that have thick superficial sand deposits that are really nice and high quality, low like clay content, things like that. And then low scores would be areas that are extremely thin sand layers or unusable primary materials. And then at each of those core locations, we extracted bathymetric characteristics. Ran a variable selection algorithm. We did a bunch of these, but we ended up predicting convexity, ruggedness, and bathymetric position index were predictors of sand quality. So this is an example of what a multi-resolution bathymetric position index looks like. And the point is all these help really amplify specific unique features on the ocean floor, more so than just looking at depth. Now we tested a variety of different predictive models to see how we can extrapolate sand quality across our study region. Ended up with a random forest algorithm performing best. That's a pretty straightforward machine learning algorithm that's pretty commonly used in a lot of studies. And then we extrapolated it, and we found, as you would predict, convex, raised off the sheet, seafloor features had high quality sand. That's shoals. And if you look at actually the modeled shoals, it lines up very perfectly with that. Then we ran a image segmentation algorithm on that to sort of isolate our model output into more usable chunks and then delineated those into what we call sand resource units. And so that these are available on the BOEM Marine Minerals Program. So they're units that can be used to prioritize further geological investigations or ecological investigations as potential sand resources far into the future. And so this graphic is complicated, and it should be, because the offshore environment is very complicated. We identified tons of potential sand resources, but we also have unexploded ordnance, and this doesn't even have a lot of stuff on it. We have artificial reefs, we have protected habitats, we have shipping lanes, underwater cables, all this stuff, so that even though it looks like we have a ton of sand available, we really don't have that much. And the key thing is that we need to be planning early to get out in front of this before it becomes a bigger issue. And then the final thing is just kind of a plug. We have entered a new cooperative agreement, and we're expanding our analysis that was limited to Delaware and Maryland to the whole mid-Atlantic, well, not the whole, but from Virginia up through New Jersey, which is obviously way, way bigger than the first study. I'm happily seeking collaborators or feedback from anyone that lives in these areas, works with beach nourishment. If you're just interested, please reach out to me. My email is on the next slide. And I'll acknowledge some help we got with some of our data gathering from DENREC, Maryland Geological Survey, BOEM, and the Army Corps, Philly, and Baltimore offices. And my email is warnerdl@udel.edu. If you're interested in our work or want to collaborate on it, please reach out. And then the Delaware and Maryland study, all of those outputs are now available on the Marine Minerals Information System, along with the project reports and technical documents and things. So I think that's about it.
Great, thanks, Dan. Okay, so we have, what, about 10 minutes? 15 minutes for questions. Does anyone have anything for either Jeff or Victoria or Dan?
Hi, so my question could either be for Jeffrey or Dan, but my question was, how much sand off the top do you need or collect? Like, how can you assume that there's going to be sand underneath of it if you're just viewing the top?
We're one of the, we collect core in addition to geophysical data, using high-resolution geophysical data, mainly low-frequency chirp systems or a boomer system, which has a penetration of, say, 10 meters to 15 meters. So we strategically place our vibrocore. That has a penetration of about 20 feet. And we're geologic mapping. And that's why all that, these data were able to be developed into a geologic map for Delaware. But basically, like I said, we're geologically mapping the subsurface. Dan?
Yeah, and also when they dredge, they tend to only go down like 10 feet max to avoid creating dead zones and pits on the ocean floor. So we're only looking at that top layer. And actually, when we built the model, we only considered anything on top of some unusable layer. So if we hit like 2 feet of clay, that would destroy a dredge head. So we just cut it off at that, just to be accessible.
Yeah, thank you. Great presentation, so interesting. And one of the images showed shoal symbolized in red, and Jim, you indicated those were either depleted or had been determined to be critical habitat for something or another. Can any of you speak more about, like, what are the criteria or something about the criteria and process for deciding that they're critical habitat? And then if I can sneak in another question, is there a relationship at all of any kind between, like, what we deem as high quality sand for human habitat in front of on beaches versus fish habitat?
So the big one in this region was Great Gull Bank, which is off the coast of Maryland. That was used to plug up a breach that happened in Assateague Island in the early 2000s, I think. And it was kind of an emergency thing. And afterwards, there was a huge outcry from recreational fishermen and clearly some major environmental impacts that happened. So they said Great Gull Bank is off limits. And that's kind of one of the things that prompted Ocean City to start looking further offshore into Bohm waters. And then in terms of sand, they usually try and match the sand grain size closely to the native grain size, although we don't really know what that is. So, you know, if it's 0.22 millimeters, we try and hit a range of a certain grain size.
So it sounds like there's not a structured process I bet there probably is, to characterize the resources as to whether they're would be withdrawn because of their important habitat or not.
Yeah, you can take that and I can finish maybe for Ocean City.
So NOAA classifies areas as essential fish habitat, which is protected under Magnuson-Stevens, but BOEM doesn't do that specifically. But for some of our studies, if we know that there's going to be dredging in an area, we can plan to do research ahead of it to identify what the habitat is, what species are there, so that we can then have a more fine-scale idea. But then there are other models, I would say. So the shoal mate study that I shared did this a bit, kind of helped map where shoals were anticipated to be, and then also took habitat distribution models for all different species that are identified as having essential fish habitat, and mapped those according to their typical habitat and where our shoals would be. So I don't know if that helps that a little bit, but then, so that's essential fish habitat, but then critical habitat is under Endangered Species Act, and so that is separate but similar in that we would have to consult for any impacts associated with that.
I just, as an example, so to speak, the most recent, one of the more recent projects was Ocean City, Maryland, which is Weaver Shoal. And even though that's not an EFH area, what was determined with consultations with the Army Corps, Environmental, and BOEM was that we would not extract more than 5% of the total sand volume from that shoal for its lifetime, and we would leave the integrity of the shoal intact. So we excluded like the crest of the shoal, so its performance would, be maintained. And we do, traditionally we do pre and post dredging surveys, but like for Weaver, every, in between that, we'd also did a bathymetry survey to see how that shoal functioned. So the whole idea is to extract a certain amount, but leave the performance intact, and then monitor that over time, and then see, what the other alternatives are. So we have general overarching, rules that we operate under, consultation practices we are under, but then we get into the fine details for each project and looking at what the resources are available. So we try to fine tune everything for every project.
You had mentioned earlier about that your colleagues in another country, I forgot where, are experiencing companies going out looking for sand for aggregate uses. Is that something that you see coming to the U.S. in the future with the demand on that? And if yes or no, is that something? Because I just know governmental agencies go to you all. Do you work with other private entities for that type of stuff?
Well, under our authority, we are able to entertain requests for competitive leasing for aggregate sources. We have not received any requests from anywhere along the Atlantic. I know that there are some interests, say, in Alaska for building roads, so they don't impact on permafrost-sensitive areas, so that kind of thing. Europe uses it, of course. I mean, most of the dredging for the UK, for example, even though they have over 74,000 miles of coastline, more coastline than India, most of it is for aggregate dredging because they need aggregate. For construction materials, it's kind of a mixed bag because engineering, you like angular material because it locks in concrete better, right? And you know, the rounded material that we have for aggregate sources aren't. That's not to say that dredging hasn't happened for aggregate material, because years ago, Amboy Aggregates used to dredge the Ambrose Channel for tens of years for aggregate. But then the aggregate needs to be washed with fresh water because the chlorides would degrade the concrete, etc. So that's an expensive proposition, and right now it's easier to get aggregate from upland sources or go to Nova Scotia for big rocks, things like that. We go really far for getting, you know, hauling stone and stuff like that. So it is possible. We haven't seen any requests yet. That's long and short of it. Thank you.
Thanks. Tony McDonald, Urban Coast Institute. For Jeff and Victoria a little bit, one is just a big fan of the language of this program, borrowing sand and nourishing beaches. It's also nice. Love that. But it's just, that's good. I know. Yes, you know, I've been so it's, I'm just going to borrow it, but I'm not going to give it back. But I guess I have a general question, which is, again, it sounds like the assumption is we will continue to nourish beaches the way we have nourished beaches in the past. And I don't know if that's necessarily going to be the case. So have you taken in alternative scenarios? I mean, demand for nature-based features, demand that maybe people, I hate to say it, might harden more stuff, giving adaptation strategies and other stuff. So is most of your work based on this assumption that the demand is going to be based on the current use? And my environmental studies question is very somewhat familiar with your programs, but how do you determine what studies? They seem very mission support, and wonder how you determine those, you know, what studies you're doing. And again, it seems like we've heard during the last day and a half the need for similar type studies, and whether you feel like the environmental studies program is well networked with other environmental studies that are going on in the region. So hopefully that's okay.
Well, I think you know, like I said, things changed after Hurricane Sandy with particularly with the North Atlantic Coast Comprehensive Study. And then when the hurricanes happened in the south, the Southern Division did their South Atlantic Coast Comprehensive Study. So taking the small phrase that came out of the North Atlantic Coast Comprehensive Study, you know, difficult choices lay ahead. We have to address requests. They request us for sand. And we have to do our due diligence to demonstrate what the impacts are to the environment, what the potential supply is for these projects. So the best we can do, because we facilitate things, is to have data. Share our data, share our projections, you know, encourage, you know, lay out what's there, what the alternatives are. Will BOEM have to say no? Maybe. You know, it's like we don't want to be in a position where BOEM doesn't want to be in the position where we said we could have done something or wasted our resources. Certainly there are impacts or decisions that we have to make. We have a lot of federal holdings, like I said, millions and billions of dollars of just infrastructure, or even say our national parks or state parks where they have And they've always had the position of saying, well, we'll just move, we'll just let nature take its course. But the irony is that their big metric is visitation. And those visitations, like hurricane, during COVID, for Assateague, for example, I was looking at the attendance for Assateague. That was from, like, there was no off season for Assateague because everybody wanted to be outside. So the overflow parking that was not paved was being overrun during, nesting seasons, et cetera. What if a storm wipes out a road to the parking area, and the alternative is to, wreak havoc on habitat? Well, maybe beach nourishment for those instances are appropriate. For me, I'd like, to be there, right? Sometimes I look at the ocean, at this situation, and I say, people, even though we do beach nourishment for, the Army Corps does it for people and property. And I look and say, people can move, habitat can't. We should protect habitat. And then with the interesting challenge and good challenge to us of ocean justice is, for some people, it's really hard to move. And we have to leverage that too and be aware of that. So like I said, difficult choices lay ahead. The best thing to do is to put science and data to help us to make those decisions.
Okay, 2 minutes left, is that?
Oh, sorry. Okay, real quick, I'll just address your question about how do we pick our studies. It's actually quite a robust process. So we do, the Office of Environmental Programs does ask for input from the public and stakeholders. And then internally, we also propose ideas. Then those ideas are made into study profiles, which is like a 3-page summary of the proposed study. Those are then peer-reviewed internally, and then they're scored based on kind of priority and relation to BOEM programs. And then I think they're elevated to leadership review, and eventually the top ones are selected based on funding that's available for them.
Okay, great. Thank you so much. Thanks to Dan and Victoria and Jeff.